friendship type of thing and being able to go deeper into those elements. Don't remember time-wise if that was actually before I created N-Service Bus or after. N-Service Bus, for those of you who don't know, it's built originally as a messaging library for .NET, originally on top of MSMQ, and then it expanded to include RabbitMQ and other on-prem messaging technologies, as well as now cloud environments like Amazon SQS and Azure Service Bus, etc. I wouldn't say that there's an extremely strong connection between most of what people interpret as domain-driven design and Service Bus or messaging in general. It's only when you get to sort of the later bits of the book where Eric starts talking about bounded contexts and the idea that you're going to want a fairly strong degree of separation and yet some amount of integration and connection between these bounded contexts. While he doesn't explicitly call it out in the book, messaging patterns are a very good way to deal with those things. The other element where messaging patterns and therefore in Service Bus connect to topics that are nowadays commonly associated with domain-driven design is when people talk about command query responsibility segregation, CQRS. So on the command side, the sending a command from the client and then processing that reliably on the server is something that historically people have done over HTTP in various ways for quite some time. And then they encounter a lot of technical infrastructural issues around those types of things. And that's where messaging can help. And then again, if you choose to do CQRS in the form where you actually have a different data store for the query side than you do for the command side, then you'll usually have some sort of eventing mechanism to take data from one side to the other. And again, messaging patterns are a reasonably good way to transfer and reliably process those events on the other side. So that's sort of a brief bit of background for people that are new-ish to DDD, bounded context, CQRS, and messaging to kind of give them the lay of the land and subsequently connect to all the other things that we'll be talking about today.
Yeah, thanks. And that really connects the messaging you were talking about to the first question that got most likes on Twitter, right? And it was like, it will be valuable to see real-life examples when SOA, event-driven CQRS were a bad fit for a problem and elaborate on why. It seems like most discussions end with it was done the wrong way. And it seems a bit superficial.
Right.
So can you?
So that was Veronica's question. Good question and a common pain point for people in these environments. On Twitter, I gave sort of one sneak peek answer, which is I said the startup context is usually a place where it is less suitable. And I know that kicked up a little bit of a storm. The primary reason is that most startups, they still haven't validated that the business problem that they're solving is actually viable. What do I mean by viable? That they can actually make enough money or have some kind of business model that results in them eventually making enough money, which is why we often see startups, the term that's used is called pivot, which is a fancy way of saying, go and solve a very different business problem than the original one that they started with. Now, historically, when I've talked to startups, or early stage startups I'm talking about, where they haven't validated that hypothesis yet. A lot of times the technical folks on there will be asking questions like, how do we find our service boundaries? You know, how much data do we put into events? And lots of very technical architectural type questions. My response to them invariably is, you're going about this the wrong way. You need to write the minimum amount of software to be able to validate the next business viability hypothesis. The successful outcome is that you actually uncover a business domain that is able to generate enough demand, revenue, whatever, that your previous software solution is barely keeping up, and then you have to throw a bunch of money at it to stand up more servers or what have you. The startup success stories that people hear about is, well, Twitter had to rewrite their tech stack 3 or 4 times, eBay had to do that 6 or 7 times. And the belief is that we can do better than that and get it right the first time. And in my experience, it's the other way around. The people that try to get it right the first time end up spending a whole lot of time and money solving the wrong business problem. And then when they find out that it's actually non-viable, they don't have any money left to do a meaningful pivot or a second pivot after that, and essentially the business folds. So the idea of needing to rewrite your software over time is something that, at least in the startup context, needs to be reframed as, yes, that's how it's supposed to be, and not to be considered as, we failed, we didn't predict things in advance, we should have built it more scalably from the beginning, et cetera, et cetera. So I think that a lot of these, SOA, CQRS, event sourcing, all of these types of things, they're premature in early startup contexts. And because in many ways it's putting the emphasis on the wrong thing. So
people forget
that category 1. Christina, yes, you wanted to jump in?
People forget that Google and Co had succeeded in the first time.
Mm-hmm.
They succeeded. It was a success, and of course you have to rework. Jeff Atwood said once about Stack Overflow, I think or maybe it was you, I don't know. You always are before the next iteration, before the next issue, performance issue. It is always the case. The question is when.
Right. So that's one category. There's another category that I can talk about that is less like that. Kenny, do you want to ask about that first category some more?
Yeah, because this goes into another question I now see running, and it says, right, in which cases should you use, in this case, command? What I usually see in businesses where they start to over engineer it, right? We need some Kafkas already because we need event-driven architecture and because we need to communicate service to service with events, right? And that's actually what you're saying, you ain't gonna need it now, so maybe just direct communication is fine at that moment. Is that what I get you correctly if you're in the startup position?
Correct. So in the startup mode, it's and I see this most commonly when the founders are themselves engineers, especially coming from sort of big software backgrounds, having built big complex systems. It is that there isn't a sufficient either understanding or appreciation for the business side of things and how to incubate something from scratch. And I'd say that a lot more focus needs to be on those sides of things. So remember, one startup brought me in and they were asking all of these types of SOA, CQRS types of questions. I said, well, hold on a second. How much load do you have right now? And their answer was, well, none yet. We haven't launched. I said, well, okay, then we're having the wrong conversation because you don't even know that you're solving the right problem. What you need to do is you need to set up some landing page and see whether you can get any traffic. So find out whether anybody is actually interested in this thing that you're doing. Oh, no, we need to be in stealth mode. For whatever reason, stealth mode sounds cool and everybody wants to do it. It's a very dumb idea in, I'd say, a vast majority of the cases. People tend to overestimate the benefit that a big fancy launch will give them, and that's a product of Steve Jobs, who was the absolute king of launches and of preparing things and really slick. But Apple had millions and billions of dollars to perfect that launching type of thing. Startups that don't have that DNA and those muscles yet should not try to emulate those practices. So there's like a lot of basics of business and management and marketing and sales and all those things that get the basics down first. Launching, that's when you're a lot more mature and you actually have figured enough things out. But this isn't meant to be a how to start up a new startup type of talk. There are lots of talks out there that talk specifically about this. So for those of you that are interested in those things, there's the lean startup camp, and then there's the business model canvas, and lots of stuff out there. Go read that stuff before going too deep into the startup side of things. So second category, and that was Veronica's question, is very much in that area of the, in what cases or what example is there where, SOA, event-driven CQRS are a bad fit for a problem. One of the examples that I've seen, and there's sort of a number of variations on this theme, but it usually comes from a certain technical assumption of, well, we're going to be using a certain technology stack. So we already have this idea of CQRS looks like this. We're going to be using SQL Server on the command side and MongoDB on the query side, or we're going to be, they have this sort of template of how they're going to address this problem in their head. So one category of that is, and it's a fairly well-known one, which is why I use it. It's the product catalog in a retail type of setting. So many people have either seen sort of a demo product catalog piece of software that said, right, you've got a product table, and a product has a bunch of attributes on it. It's got, a name, and it's got a price, and it's got all of these types of things. And then there are categories, right? And then you can have a category that's nested in another category. And I'm like, great, what's the problem, right? Simple, easy, and off you go. Now, what makes this problem domain interesting is that in the in sort of the business world, it's a domain that often has a high degree of requirements. I wouldn't necessarily use the word volatility, but evolution. The business often comes to us frequently and says, we want another attribute on a product. So a product has a shipping weight, and we're like, okay, great, add another column to the product table. And then you get some more information about the category, saying, I want to be able not only to search based on price and based on category, but certain types of products. For example, once we get into different products, it's if you're talking about clothing or apparel, a product can come in different colors. So they'll say, okay, we want to have a color attribute for products. Developers say, great, we're going to add the colors available attribute to the product table. But then you have, what does that mean for books? Because books don't come in different colors, right? You can't say, I want the domain-driven design blue book only in red. Well, that's Vaughn's book, but it's a different book at that point, right? So you get this sort of trickle of requirements of the, now I want this, now I want that. And we keep kind of adding another attribute to the product table as we go along. Now, when trying to do SOA, CQRS, all of those types of things, event sourcing as well, a lot of times, sort of in the early days, what we're doing is, especially on the events between the command side and the query side, is that every single attribute that is added to the command side is subsequently added to the events, and then is subsequently added to the query side. So essentially, we're having to make the change in more places, but because these changes are happening frequently, then especially for the folks that do the event sourcing with a kind of replay of the history behavior in it, then things get more and more complicated over time, because essentially for a given running system, that's the thing, you tend to get this sort of trickle of new requirements when the system is running. It's not that you kind of get all of these things before you launch the system, and then you launch the system and things are mostly stable. It's, you know, this sort of stream of ongoing changes to requirements happens all the time. So you're having to make these changes to the running systems, to their data models. And then when you're replaying events, you end up having to replay lots of old versions of events. Now, so long as you're only adding columns, that's mostly okay. But at some point in time, your DBA is going to tell you, hey, guess what? There's a limit in SQL Server on how many columns you can have in a table. And then you're like, oh crap, what do I do about that? You know, you have that problem both on the command side and on the query side. So, and then people want to do all sorts of queries in sort of weird ways. You know, when I'm searching for apparel, then I want to be able to search by color. When I'm searching for things that are not apparel, then I don't want to have the color search to be available. And then people start trying to say, okay, we're going to put categories and we're going to subdivide, we're going to have them in different tables. And it starts to get quite complex fairly quickly. And the problem is that there's really nothing in, let's call it the CQRS event sourcing, that makes any of that any easier. In many ways, it actually, the technical design choices exacerbate the pain of those types of changes. So, and also the underlying data technologies, they're usually when people choose them, they're saying, okay, I'm going to use SQL Server for this, and I'm going to use Get Event Store for that, I'm going to use MongoDB for this other thing. The understanding of the volatility of the data model and sort of how big, how many fields you're going to have to deal with. And the real painful thing on, if you're doing CQRS, it's on the query side, but even if you're not, it's still on the same database, is essentially users want to be able to query by every attribute that you've got. So I would like to see all shirts that come in blue. I would like to see, you know, all books that are on the topic of SOA. I would like to see all watches by this manufacturer. I would like to see all, you know, children's toys for children's between 7 and 9, right? Almost any attribute in the product table is something that somebody's going to say, I want to query based on that, which means essentially you need to index every single column that you have there. So I could go on and on about this domain. I've been talking for about 5 minutes or so to kind of give you the lay of the land, but it's one of those things that when people look at the problem, they underestimate its future volatility and complexity, and how their technical choices are going to potentially hinder their ability to continue to evolve the design to handle all of those things. So that problem domain is one of the reasons why initially columnar data stores were created. So the better known one out in the wild today is Cassandra. But before that, there were a whole bunch of columnar data stores that were created that were more enterprise targeted at major retailers that were building these types of product catalogs. Vertica was one of the better known ones, where essentially the idea being that we don't want to have, to use the term row, not all rows actually require the same columns, right? When you're talking about a book, there are certain attributes that are relevant to books that aren't relevant to shirts, and certain attributes relevant to shirts that aren't relevant to books. So the tabular sort of the relational database model where all rows have the same number of columns is something that is not a good fit for this domain. So similarly, when you're choosing your persistence technology, those are things to evaluate. How is this domain going to change? And one of the common mistakes that software developers and architects make, and the reason it's common is because we're trained for this. We're trained to look for things that are similar, right? It's the behavior of find an abstraction, pull out a base class, basic object orientation, all of those things. So we seek out things that are similar, and we make those things the pillars of our design. We don't nearly enough seek out what is different and how those things may evolve in different trajectories from each other to be able to say, actually, those things are not similar enough to be put in the same place, to be modeled using the same domain model, to then be put in the same bounded context, et cetera, et cetera. So I'd say those are the common mistakes. And Veronica, to your question, hopefully that gives you a real-life example where these types of CQRS, SOA event-driven type of things, when they are approached from a more technical first approach, which often I see in the DDD community that they are, that's where people get into trouble. And not really starting from the domain side and spending enough time to understand how this thing can evolve. And the fact that, hey, we're not the first people building a product catalog. We, instead of spending hours and hours reading up about CQRS and those things, maybe we could spend some time reading up on the product catalog domain, and that there are patterns in the business domain side of things that we can learn a lot from and help us in our modeling. So that covers about 10 minutes on that topic. Follow-up questions on that?
No, there was another question there, and maybe that goes into the heuristic you have here. The other question is why is it a bad idea to duplicate volatile data? And I think you covered that quite well here, right? If something is volatile, be careful with using things like CQRS, because you're actually duplicating that volatile data. If the change rate is high, it's similar to if you extract like the REST model side and the entity framework model side from your domain model. There's translations going on there, and it's also essentially a bit of coupling where you need to change places, change things that has a business change leads to multiple changes in your technology.
So we need to differentiate the duplication versus replication terminology, because a lot of times people use them interchangeably. Duplication is where essentially we're creating logical structures that are essentially overlapping in logical structures of other places, right? Now, usually that means that we're also physically replicating the data from one place to another. But the most important thing is to distinguish that logical versus the physical. So if, for example, I'd say the most basic one is database level replication that we're all familiar with, right? You got your primary that you're writing to, and then that gets replicated to the replicas. And that is often done for scaling out the reads. So essentially, it's the same table structure that is in your primary database and in all of the replicas. So there's no logical overlap. Logically, it's the same definition, but you create multiple physical copies of that. So that type of physical replication is often done for technical load reasons, often done for high availability reasons, right? Then we can take a replica offline and we can put another replica in its place. For geographic redundancy, so if we're building a worldwide available type of solution, then we don't want everything having to traverse the entire internets to get to a specific server in one specific location. So we replicate the data in multiple places, but essentially it's the same code base, it's the same logical structures. That's replication. Duplication is when we start saying, no, it's not the same logical structure. These are different bounded contexts, business domains, where essentially the same fields are put in either place. That's where things start to become tricky, because first of all, and this is the other part about volatility, when people talk about volatility, there is the rate at which the data itself changes at a physical level. So the customer record, the product record, how quickly is the data itself changing? So you have that data level volatility. And then you have the above logical level of volatility that I was talking about before, the definitional. So how we define a product now has another attribute, right? So that is definitional volatility versus the data volatility, logical versus physical.
And I know Paul Reiner calls that one the connaissance of name, right? So the naming there, the attribute has a name which has a meaning in your domain. So there's a connaissance. If I want to change one, I need to change the others as well.
Right. So the other part that's related to that is that once you've created a logical duplication, the first question is it really meant to be the same, or is it meant to be different? So once you've created the separate definition, that creates the opportunity for forgetting, if you will, that one team changed one bit of code and they forgot, or it was the responsibility of another team to change another bit of code and definition. So it opens up the opportunity for sort of a divergence of definitions, and then that creates subsequent problems down the road. So if things are supposed to be the same, duplicating the definition makes it harder to maintain that logical sameness over time. Now, if they're different, then at that point, it's not really duplication anymore. You're defining a new different term, and there might be some relationship between them. But I think the most important thing when people get into these questions or into these situations is to be specific. What exactly are we talking about? When we say volatility, are we talking about data volatility or logical definitional volatility? The example that I gave of the product catalog illustrated a bunch of logical volatility, additional changes to the definition of what product means, right? Versus I want to keep the data that is shown to people in search results fresh, whether that's based on prices or anything else, so that when they click through from the search results to the actual product page, they don't see two different things, right? So that is a case where having a copy of the data for search, which is optimized for search purposes, is a physical form of duplication and reorganization for technical reasons. But logically, the terms are meant to mean the same things. So in all of those areas, it's back to the question of why should we be careful with volatility and duplication? It's the point A that I mentioned before, if you're duplicating the definitions, they can diverge when they shouldn't, right? The flip side being, if it's the same thing and you're doing replication, there is no problem with it. Just be aware that you're doing it for technical reasons and that those technical reasons are justified. So if you're creating, if you think you're doing physical replication, but you have two different teams that can start changing the definitions of those structures, then the thing that was meant to be logically the same might end up diverging as well and turning into that sort of definitional duplication without any really clear ownership around it. And then the other case is when it's actually supposed to be different, but it looks the same. So I don't know, we use the term customer, say, oh, we've got a customer here, we've got a customer there, and we've got a customer there. But in different environments, it's the support people, when they're talking about customer, what they actually mean is user, right? They're talking to so in a given customer account, there may be a large number of users, each of them having different questions that need to be tracked and different, make sure that the response times are being met. So if we use the term customer in the support context, it muddies the waters. And if we talk about in the accounting context, then again, it's a question of, is one customer in the sales context mean the same thing as one customer in the accounting context? So, so even there, it's just, terminology, make sure that we're talking about things correctly. And that's where techniques like SOA and starting to partition things and be more specific about things can help. But that requires me to expand a lot more about SOA, and I want to be cognizant of all the other questions we need to get to.
Yeah. Yeah, thanks. And to go on that, because we were talking a bit about coupling, right? And well, one question that was there, if we do use communication by integration and domain events between the bounded context, what would be some pointers or some heuristics you have to avoid coupling between these contexts, right? Because that's what we eventually try to do with the bounded context, is try to, well, let the system be more autonomous. Right? Be more decoupled, which you can't, but as lowest as possible.
Right. So first of all, we need to have certain assumptions that both the software, the business, the organization is actually mature enough in order to be able to find good boundaries and then maintain and execute on them long term, because a lot of times those preconditions don't exist, like I mentioned in the startup context. So we need to make sure that the overall context that we're in is such that supports those things. Now, assuming that those contexts are there, then there's a number of supporting patterns that need to be in place, and let's call them metaphors. First one being that a lot of times when people talk about bounded context, which is a logical term, they connect that to a physical, or let's say to a code base, first of all. So you have, maybe I'll start at the beginning. You've got subdomain in DDD terminology, which is, let's call it more on the business domain side of things. Then in Eric Evans' terminology, bounded context can mean a number of things. And I don't want to get too much into that. But I'd say the guideline that I recommend, and that has a fair bit of history in the software architecture world, is that you want to try to have a good mapping between your solution domain to the problem domain side of things, okay? So that means your code base to the subdomain, all right? Now, so I'm skipping over the DDD bounded context term to use the more clear code base statement as the first part of the solution context. Now, the other part is to say, well, you know, the subdomain, how broad do I take it? Again, one of the common mistakes that occurs is a management one, where things are coupled too broadly. So the project management part of the business world says, I have a problem to solve, right? So that's business domain type of thing. I'm going to, you know, in my head, not even realizing I'm essentially doing design, I'm going to choose which team is going to do that. And by proxy, which system that's going to be implemented in. Now, system is a unit of deployment. Team is a unit of personnel organization. And then you've got the code base itself, and then you've got the data underneath it. And so there's a whole bunch of things here that are decisions unto themselves. It usually, even before any work is started, all of those decisions are established and essentially coupled to each other, where this business problem is mapped to the team, which is mapped to a system, which is a unit of deployment, which is mapped to a code base, which is mapped to a database. And whatever level of overlap there is between other teams, other code bases, other databases, et cetera, is just sort of, you know, very briefly glossed over. Then, you know, team, this is your job. And then it's a, you know, should that really be our job? Should we really own all parts of it? Maybe we should own this part, and that other team in that other code base and in that other database should own this other part. And essentially, we should be collaborating with each other in solving this bigger problem. So a lot of the mistakes of the situation that you're describing are mistakes that happen even before the team is sort of made aware that, that there is work to do. And then when they're given the work to do, then you sort of end up finding out later on things that we did overlap with things that other teams have done in the past or are doing now. And part of the reason why those things occur is politics, and business managers, folks are fighting over responsibility between each other and going behind each other's backs. It's a whole mess. So when we say, oh, we've got a mess in software, what should we do to fix it? A lot of times the mess that we have in software is essentially a reflection of the mess that occurs in the business and the management side of things. So a lot of times people say our problem in software is we're not well enough aligned with the business. I'd say that in many cases, the problem is that the business world is too chaotic and not really well organized. We could be perfectly aligned with the business and we'd still have all of these problems. So a lot of times the solution is for us to try to compensate for the lack of good boundaries in the business and in the management and in the project management sides of things, which is really difficult for technical people to do, because now we're not only doing our job, we're doing a whole bunch of other people's jobs along the way. Now, given all of that, getting to the point of saying, that's why I said about organizational context needs to be mature enough when going to engage in these types of practices. When all of those pieces are in place, then you can say, all right, the subdomain is best divided up into these chunks where the only bits that need to connect them are an identifier here and an identifier there. And then, this code base and the database underneath it deals with this ID and those 5 attributes. That code base over there deals with same ID, but 4 other attributes, and has its database, and I have my database. And then we have some sort of composite UI that stitches those things together so that the end user sees just one thing when they're looking at a customer account, an employee record, a product details page, what have you. But to your question, which you started from, it's the events that connect between these two things. When you do that exercise well of all of those upstream things that I said, what you'll find is that the events that occur usually don't contain a whole lot of data in them, because essentially we've teased apart all of sort of the subdomain level things to say, well, I don't need those attributes on my side. So when you make a change over there, you don't need to issue a domain event or an integration event saying, I changed X, Y, Z, but the ID is still the same, right? It's like, well, yes. But, well, I don't care because I don't store those fields on my side of things. So, and that's that whole duplication story of saying, if we don't duplicate, if I don't have the same definitions on my side that you have on your side, then we don't need to include those fields in the events. And in some cases, we don't need events at all to propagate changes from one place to another. So the nature of the events starts to change and become more reflective of the business. So instead of something like product name changed or product price changed or all sorts of very data-oriented events, you often end up with things that are higher level things. The product is no longer for sale. So all that event needs to include is the product identifier. But then you have different business capabilities and or code bases. Oh, product's not for sale anymore. Okay. In the search context, that means we need to stop including it in the search results. So that behavior is done over there. In the shopping cart context, say, well, people that already have this item in their shopping cart, well, they can finish their checkout if they're online right now. But if they don't, and if their shopping cart goes to sleep, then when they come back, we will have removed that item from the dormant shopping cart. So that's a behavior in the shopping domain when a product is no longer available for sale. So you may have that when you have a manufacturing recall or something. It's not safe to sell that product anymore. Then you have in the inventory side of things, which is, well, we stop the automatic inventory replenishment for products that are not for sale anymore, right? So here are examples of different domains likely holding different information, different fields about products, where each of them is behaving differently off of the back of an event, product no longer for sale, that all it contains is the ID. So those are the types of things that you'll see as more common archetypes of both events and the behavior of processing the events. So lots slimmer events, and the kind of thing that you say, well, it isn't clear why exactly the shopping cart world would need to overlap very much with the inventory replenishment world, right?
So would that be a heuristic you're using? If there's too many fat events, maybe my boundaries are incorrect here in the communication. Maybe there's something wrong on the way the business, well, maybe business communicates or project, right? At least there's a smell here.
Yes, indeed. So fat events are either an indication that what you're doing is essentially a form of data replication, but then essentially you're saying it's not integration events at that time, they're replication events. It's a mechanism that I'm doing to keep in sync multiple copies of the same logical thing. So long as you say, all right, these are not distinct, separate logical things, they're physical replicas of the same logical thing that are within the same logical boundary, then fat events are how you do data synchronization replication. That's fine. It's when you intend to be in the logical world and having different things at a business level, then there I'd say, yes, fat events are a smell, that the boundaries there aren't good.
Yeah, interesting. And what interesting me is you started about not naming bounded context, but naming these subdomains, right? The problem space, solution space. And there's been a lot of debate and questions as well. Is this useful? And especially, well, I know Trond was asking this question. Would love to hear your perspective on the current discussion regarding solution and problem space, as well as the need to define some more concrete building blocks in DDD, like on that side, like subdomain, core domain, and for people, it's too ambiguous. What do we mean with a subdomain, right? What are these building blocks? What are your perspective on that, and what's your perspective on these building blocks on the problem space side? Perhaps it's a problem space.
Right. Well, I'd say that the field of software design and architecture, with the introduction of patterns, I don't know, 30 years ago, ish, 25 years ago, I think was it the Gang of Four that came out, sort of the first time of saying there are these things that are patterns, they're replicable types of things, and then the pattern community around that essentially created certain templates for how we define patterns, and one of the main criteria for that was set in the pattern community in those early days was crisp, clear, unambiguous definitions. It should be, we should try to minimize the overlap between things. So if we use a certain term, we should use that term consistently and have its meaning be clear and unambiguously different from a different term. And seek to do that across essentially a number of dimensions. So, for example, that element of saying there is a problem domain and a solution domain as a certain discrimination of dimensions, so that we don't use the same terms across these different spaces. We're actually going to name those spaces. and say, there are, Martin Fowler wrote a book a while ago of analysis patterns, and say, and the terms that are used there are sought to be distinct from patterns that are subsequently called the design patterns side of things. So I'd say that seeking out clear and ambiguous terms where we can also relate patterns to each other and say, there is this pattern and there is that pattern, and each of them solves a distinct problem is helpful. So one of the things that I think in the domain-driven design, in the original book, the beginning of the book was quite pattern-oriented in terms of entities, value objects, repositories, etc. So it's kind of connected back to that pattern community where, clear, crisp definitions, they're very distinct from each other. Use this for this, use that for that. And there's a very low probability that somebody's going to mistake, a value object for a repository for an entity, or an entity for a value object. So those bits were quite good. It's when we got towards sort of the latter areas of the sort of strategic design where I found that things were not nearly as crisply defined. There was a lot more ambiguity and overlapping, saying, bounded context. What does that mean? Is it purely linguistic? Does that include code bases? Does that include deployment environments? And the answer that I got from Eric when asking that was, yes, it can include each and all of those things. And I think that overlap actually creates ambiguity, because when I say the term bounded context, you need to subsequently ask me, wait a minute, are we talking code bases? Are we talking linguistically? Are we talking, what do you mean when you say X? The whole point of having a pattern language is so that I don't have to say 5 sentences when I can say 2 words, right? So, and I think that bit was missed in some parts of DDD. And in order for us as a community to resolve those issues, we essentially need to stop using those terms and use terms that already exist in the pattern literature, and or come up with new terms, so that when we talk about a certain code base, and people asked me this a while ago, I said, okay, so when you say SOA service, what does that look like in code? I said, that's a source control repository. When I say the term source control repository, that is an unambiguous thing. You know exactly what I mean. Said, that this is, this field of source control is well defined. And the thing that is in there is source code, right? It's not executable unto itself. When I tell you source control repository, there's no way you can mistake that with a running system, right? So I think that we as a community, in terms of moving ourselves forward, we need to find and make more use of existing terminology, source control repository, packages, for example. It's when you compile and package code in a source control repository, what comes out of that is not a running system. You get a bunch of packages, right? NPM packages, jars, wars, .NET assemblies, et cetera, et cetera. Then those assemblies, those packages get pulled through various types of mechanisms and put together into executable environments, right? But there is a set of transformations that occur on one or more source control repositories that ultimately results in an executable process, right? And again, we want to distinguish the executable process, meaning all of the packages are there, all of the configuration is there. This thing now can run, versus an actual running instance of that thing on one or more servers. So all of these things, they have names in the software world. We don't use them nearly enough. And then that creates or essentially we lose degrees of freedom in our solution space, because essentially we interpret the running system with the code, essentially ignoring the fact that there is a whole field of transformation that can be done, and a certain number of degrees of freedom to say, actually, there's nothing preventing a running system, right, an executable process, from having code that's coming from multiple source control repositories, right? But naturally, or I don't want to say naturally, it's quite common that the assumption that a executable process equals one source control repository.
Yeah.
That's often how teams go about designing software. Because multiple source control repositories, that's too heavyweight, whatever, that's too hard. The other thing that we presume is source control repository equals team. And again, that question or that decision is something that needs to be validated. So there's a whole bunch of things that happen in our world of software development, maintenance, operations, deployments, all of those things that unfortunately we've been ignoring and throwing out degrees of freedom, which then essentially challenges that we end up dealing with, we have fewer tools at our disposal. So if all you have is a hammer, then you end up not being able to build very elegant furniture, right?
Yeah.
So that's when I'm talking about degrees of freedom. Essentially, it's tools that are at disposal.
So what you're saying, and I know the community is doing so, is trying to, well, and Rebecca Wirfbrock, right, constantly says is patterns evolving, make sure to write new ones, they might evolve, rename them, rethink about them. That's something that you're going into as well. And I know some members of the community is already doing that, right, especially the
being more rigorous, more precise.
Yeah, more precise.
And being able to say that that is a deployment concern, which is distinct. There can be deployment patterns. Those are distinct from the source control patterns. A lot of times when we talk about, use the term coupling or decoupling, it's how do we couple or how do we design things? First question is, in which domain are we talking about? Is this code in the same source control repository or in different source control repositories? We often don't even start with asking those questions. We presume a whole bunch of things, and then it's how do we couple or how do we share or how do we? So it's realize that there are those things and have rigorous definitions and be aware of those tools. And yes, it would be good for there to be more rigorous definitions, more precise definitions, broader sharing of those definitions and use of them, whether it's in conference talks or in blog posts or papers that are online, Twitter, just sort of the general conversation, that we make our language more precise, because that will allow us as a whole to sort of lift the quality of the discourse.
We have a question here from Trond. Don't you think that this ambiguity was intentional?
Do I think that the ambiguity was intentional? I don't think so, in the sense that after spending many hours and many days with various members of the community, as well as with Eric Evans specifically, people just have sort of different natures, a different sort of inclination for specificity or generality, and certain ways of thinking. I'm sort of more of a, things that I like things that fit into neat boxes and clearly defined relationships between things, and because that's what's natural to my brain. Somebody else whose brain does not naturally think that way, to them, what is right and good and should be emulated is things that are more free-flowing and not nearly as rigid. So they might look at the thing and say, the domain of software is constantly evolving. Requirements are changing. We're learning all the time. the fluidity of that environment should be represented in a more fluid and less rigid form of talking about things. And that is an absolutely valid interpretation and recommendation from someone who thinks in those terms. I don't think there was any intention to obscure or to take things that could have been, that were viewed as clear by a certain person, and then to make those things intentionally ambiguous for others. That's not my interpretation of what happened.
Okay, I didn't talk with Eric about this, but I can imagine that 15 years ago, it just wasn't at the time yet. The time didn't came. How did we work at that time? We didn't have the question about teams or organization or autonomy. All these things appeared later. That yes, one deployment unit or one repository means one team, maybe. This bounding to organization, it wasn't the time. Or maybe he just he specialized everything what he was sure and let air and freedom and innovation for the rest.
My interpretation of it is that it's largely rooted in the fact that this field has just been growing so incredibly rapidly for so long, saying, you got double the number of programmers in the industry every 5 years, meaning that, it's almost impossible to be aware of prior art because new art comes out at ever expanding phases. So the idea of different team structures and matrixed organizations and source control systems, people were using the tool set from Rational, the Rational Unified Process and Rational Rows for modeling things. And, I worked in a number of projects that had multiple teams and had gone through a lot of these same sorts of questions. The term domain-driven did not occur at the time because it was not actually in the literature. That's pre-Evan's book. But to say, I'm not sure I'd say that it wasn't the time, because a lot of these things were questions that were discussed in various places. However, again, just the field grows so rapidly that people sort of grow in an area that is far enough away from all of those other things. And it's impossible to find out everything that exists, right? You never get any work done. That doesn't mean that you shouldn't share your insights and that other people who find those insights valuable shouldn't make use of those things. But that's part of why it's helpful to have a more diverse and inclusive community and people coming from different backgrounds and saying, well, actually, we've dealt with those things over there for 20, 30 years, and this is what we've been doing. This is how we've been solving it. And I don't know, it seemed to work fine over there. Maybe we bring that over here. But for that, you want, more of that cross-pollination and let's call it less of sort of an internal focus of, what did Eric mean? What sort of the one true scripture that we should all follow as it was handed down from the elders of DDD. That there's always prior art. There's always different understandings in different places. And I think that the solution is rooted in sort of going broader and including more and learning from more sources, incorporating, linking, and then also sharing our insights back to those environments. So I think that's one of the things that I find a little bit worrisome is that we continue to put an emphasis or an identity around the DDD elements of it, which may promote a more internal looking focus and not enough of a let's look outwards at other fields that don't call themselves domain driven and don't use that type of terminology, but still may have a lot of good stuff for us to learn from.
Sure, and this is changing. We have this discussion. Last year, we finished the year with a huge discussion about what does DDD means. And I think not many people said the book. Most of us, me, for example, for me, the book is only the implementation detail. all the stuff all around, it's so much bigger, and it began before and not by the book. The book, if I am at the place to think about software, I solved a lot of problems already. So we don't have time.
let's go because we're talking about the ambiguity and being precise, and that's the next question from the Q&A now, right?
Yeah.
So you have a great definition for the term service. It's a technical alternative for a specific business capability. Do you also have that short definition for Saga and aggregates? In my naive understanding now, Sagas are aggregate consuming and producing events. That's the question.
Okay. So there is the term Saga in the context of software was originally coined in a 1987 paper that was rooted in the database community that talked about a solution approach for long-lived transactions. So that is the historical context of when that original term was used. The idea of long-lived transactions, as it was represented over there, was a product of the times. Now, what do I mean by that? In those times, what you had was largely single user applications that were getting more and more widely spread across organizations, and organizations realizing that sharing data between users is important and helpful, so that you actually have coordination and people are not doing different things, right? You want to have the left hand knowing what the right hand is doing. There were two competing architectural schools of thought as to how that should be handled. So you had the messaging folks, the what was known as Enterprise Application Integration, EAI, which essentially said, we're going to pass messages. We're going to, essentially the applications, the idea is we don't want to or we can't change them much or at all. So essentially, we're going to have this thing in the middle, the EAI broker, that is going to pass along things between all of these apps. That was essentially school of thought number one. You had school of thought number two, which was the relational database community, that said the solution is essentially put all of those applications on top of one big database. Because once all of the data is in one place, then you've solved the problem, right? You don't have the problem of enterprise application integration anymore, because essentially you have one view of customer, one view of product, one view of everything. Now, the fly in the ointment of the central database that all of the applications are sitting on top of is that the programmers that were building the single user applications, even if you were using a database driver that could then point to a central database, was that you could be lazy, right? So when the user clicked edit to go into edit a field or a record, programmers at the time issued a begin transaction statement. And then as the user modified things, they issued update commands and whatever. And when the user clicked save, then they would commit the transaction. And if you're building a single user application, that is a perfectly valid way of managing data. However, when you are now having hundreds of applications all doing that on top of a big central database, now what you have is this problem called long-lived transactions, which we know nowadays, leaving transactions open for long periods of times creates problems. It doesn't scale, right? You lock out other users. So that was the problem context of why long-lived transactions were an issue and why a pattern was even sought to be created to solve that problem, right? That's the historical context of the original introduction of the term sagas into the software world. Now, the thing that is not discussed nearly enough is that even though we're now in a different context, realistically, you don't hardly ever see anybody doing those same categories of long-lived transactions, right? people don't leave transactions open for long periods of time. They know not to do that, right? It doesn't scale. But the issue is the business side of things, that the examples that are given for sagas are in many cases the same examples that were given, whatever it is, 25, 30 years ago, when the paper was written, and still taught in universities, which is terrible. So for example, the transferring money between different bank accounts is described as a kind of transaction, saying, well, you decrement the balance of one, you increment the balance of the other, but that requires you essentially to lock both of the account balances while you're doing that. Luckily, the financial system doesn't work that way, because otherwise it would grind to a halt, because everybody's locking everybody else's databases and just nothing will happen. So essentially, the thing that is described as a long-lived transaction is broken up into a sort of a series of smaller transactions, and that's essentially the Saga pattern. Now, the thing about the Saga pattern, again, as it was originally written, is that it talks about compensating actions that essentially bring you back to the original state. Why? Because there's the assumption or the definition of transaction is that they're ACID, right? Atomic, consistent, isolated, and durable. Now, once you split a transaction into multiple different technical transactions, first of all, it's not really atomic anymore, right? It's not either all done or not done. You're actually exposing the interim state. As a result of that, you're not either. You're not isolated, right? So when you transfer money from account A to account B, there will be a period of time where the money is neither in account A nor in account B. So those elements of saying we're going to take a business activity, I'm going to use sort of the more general term of the thing that we're trying to do, and modeling that as a series of steps. That business analysis is something that needs to be analyzed first and foremost at the business level before we run ahead and start saying, how are we going to map that to technical levels? The reason for that is that a lot of times the business folks are not really good at thinking about failure situations. They just sort of give us, build this functionality, implement this business activity, what have you. The area where this becomes complicated is, again, because you have multiple users that are all working at the same time, doing different business activities, but on sort of a larger shared set of data, that the collaboration between them is usually not something that is deeply enough analyzed. So this comes back to some of my comments around commands in the context of CQRS saying race conditions don't exist. So the problem is that when people approach these types of things and analyze business workflows or business activities, they almost always analyze them in a single user context, which is essentially the way that people thought about sagas 25, 30 years ago. But the world is very different and they require different business analysis techniques. So in order to have things work at a collaborative level, you often need to fundamentally change the business problem. So one example that I give in my course is, for example, reservation systems. They say, well, reservation systems, Ticketmaster or whatever, people go in online and they start, reserving these seats or those seats or whatever. And if those seats are taken by somebody else, then the command fails. Ergo, there was a race condition, right? Two people selected the same seat. You can't have both of them succeed. So, it's not even a question of saga, not saga. It's the, just sort of the business activity itself. If the command is likely to fail, the transaction is likely going to need to either technically roll back, or you're going to have to perform a compensating action in order to get you back to the original state. Now, a lot of the problem is people are talking about the technical implementations way too soon before really understanding the business problem and solving the business problem. So in the interest of time, I'm going to make a long story short. The problem of reservation systems at scale is that essentially they're set up to be competitive, not collaborative. So everybody wants the best seats. And then essentially by exposing the raw data model, these are all of the seats, are they taken or not taken, creates a lot of technical challenges. The better model, and what was ultimately implemented in the London Olympics, which I was thrilled to see that they did, because it was a thing that I was talking about for years in my course before them. So I can say, hey, there's at least a good chance that somebody somewhere over there actually listened and did this thing that I mentioned, is that instead of having people select their seats, people essentially say, I want a certain set of seats. But in an area, there's a block here of 100 by 100 seats. And that's what's available. You can say, I want 5, but you don't get to say which 5. And so the system gets commands that are coming in. Someone says, I want 5 seats, I want 4 seats, I want 3 seats, I want 10 seats, I want this. And essentially it's able to take all of these requests. It changed the user interaction model. It changed what's even the command means from I want those seats to I want any 5 seats. By changing and shifting the business problem, then the software that does the processing can say, well, I'll rearrange all of these reservation requests to fit into the optimal space. And then I'm able to make the maximum proportion of those requests succeed. But essentially, by doing that, I've changed what I even think about as, first of all, what's shown to the UI, what's the command, what's the domain model that is processing those requests. So a lot of things start to change, but it comes from a seeking to model the collaboration, the behavior of multiple users with regards to the system, and optimizing for the whole. And then subsequently saying, all right, let's craft a domain model that looks at finding an optimum. And that's where, when I use the term Saga / a long-running process, it's more in that category, where the term that to use not an in-service bus specific term, Saga, but a more general term, to say what you want there is a policy object. And that policy object essentially takes in a number of messages. They may be commands, they may be events. And over usually there's a time horizon for that thing, runs a bunch of logic and says, okay, the best way to seat all of these reservation requests that I received within the last 10 seconds, 5 minutes, whatever, is this way. So when you do that, essentially the aggregate becomes that policy object that is receiving and managing all of those messages, and usually time as well. So in service bus sagas, in so much as they are designed for handling multiple messages, providing state management, and managing the passage of time, are a good implementation technique for implementing those types of policy objects. So there's that category, but you only find those types of software design patterns after you've done the business analysis from a collaboration-focused perspective. And often that ends up resulting in much better solutions. Users are much happier. They don't end up having to refresh their screen all the time, having problems getting into the system, etc. More of the commands succeed. You have lower on the system. Many things go better when you're solving the right business problem the right way. So that's category A. Category B is when you're doing integration with, I'll call them third parties. So one of the examples that we've got some documentation for is, let's say, shipping. So you get orders that are coming in and you need to ship them. Now you have a preferred shipping provider that gives you the best rates. So you want to ship with that preferred shipping provider most of the time. The problem is sometimes they're down. So under the cases where your preferred shipping provider is down, then you fall back to talking to another shipping provider. which is slightly more expensive, but you have sort of better guarantees that things go out the door. So that's a case where oftentimes you'll have this sort of long-running process where it's more process managery in nature, that you have sort of a single defined message that kicks it off. Then it says, send a message over here. If I don't get a response within a certain period of time, then I perform this other action. And then, hopefully that is successful. If that doesn't succeed, then I perform this. So you have a certain kind of well-defined set of steps where it's process management territory. And that is often distinct from the policy situation that I described before. Now, the fact that service bus sagas as a technology can be used for both of those things, they're not the same pattern. And I'd say that latter case, the process manager, usually the state is not of a great deal of interest after the process has completed. So it's just which shipping provider did I use, and kind of recording that, and then, all the interim state gets thrown out. So in those cases, most of the time people wouldn't look at that thing and think of it as an aggregate in DDD terms and say that's a process manager. So when integrating with third parties, you'll often do a process manager style, which is get a thing that comes in which triggers the process, talk to A, talk to B, talk to C, manage time, whatever, and you're done. The mistake that I see that happens is people use the process manager style for collaborative domains. And they say, and the reason that they do that is because they don't spend the time to think of them and to analyze them as collaborative domains. They say the user did this, I performed steps 1, 2, 3, 4, same kind of process, long-lived transaction as the original 25 years ago, leaving a transaction open for a long time. That's the mistake. So you don't want to be using the process manager pattern in collaborative domains, because usually that's an indication that you're thinking of them as single user in the first place. So you want to take several steps back and up. When you do that, you'll find this more policy object pattern, which often takes in multiple messages. It's not nearly as sequential in nature. Usually there's a time component in it because I'm not just going to let the collaboration happen over days and weeks and whatever without doing anything. And those are parts of the mechanisms of being able to manage good collaboration. So when talking about sagas, I'd say that it's the first step is in terms of clarity, are you in a collaborative domain? Spend the time analyzing that properly. You'll find a more policy object pattern where it is handling multiple messages and time and needs to manage state. Or are you more in an integration scenario where it's much more process manager pattern style? And then, once you recognize which area am I in, which pattern am I doing, then you can start using the appropriate technology for that.
I think this is what's meant with coupling of events. Because if you're using process manager for collaboration, then you are coupled over the boundaries.
Right. So essentially the higher level, let's call it architectural style of the process manager pattern is the enterprise application integration. So often that is where you have sort of business process orchestration. In the Microsoft world, that would have been BizTalk. In the open source world, you'd have WSO2 and all of those other types of ESB technologies. You may sort of drag and drop and sort of draw out various workflows. There's BPMN, the business process modeling notation, BPML, the business process modeling language. So this idea of orchestrating a number of things as a kind of process is a thing that has been around for quite some time. Doing that at a large scale, at the level of multiple systems type of thing, tends to, as you were just saying, Christina, result in a whole lot of coupling, ends up being very brittle, often ends up performing very poorly. because the process manager pattern, while it's great in the small, in a certain isolated integration domain, doing it as a full-blown architectural style usually is not appropriate.
Yeah, great. I think, well, we've been talking now for almost, close to
Not
1.5 hours. Well, yeah, it was really interesting. So what I hear back, a pattern that keeps emerging, and that's also within DDD, well, essential to DDD, is you need to design your business domain first. And that's usually a problem I also see coming back. Usually developers are only used to implement requirements instead of, well, we need to make a collaborative space together to redesign maybe even the business process here. And I see that thing popping up back in all the answers you gave, right? Yeah. Look at your business process and analyze that more. Start there without jumping to conclusion inside all these technical patterns. Yeah.
Oh, to be fair and let's call it understanding of most people's, most developers' contexts, if they did try to ask these types of questions and to engage in these types of conversations, the type of feedback that they get from business and management type folks is that's not your job. We will tell you what to build and you will build it.
And we already spent half a year thinking this up, so we won't change it.
Right. So if that's the cultural organizational context that they're in, even attempting to go about doing that exercise is it's difficult. The other thing that's problematic, also related to that, is that in the past, what's called business analysts or business analysis as a profession was something that was established and identified as having a meaningful and distinct skill set from the programming side of things. And in many organizations, that role was deprioritized and sort of degraded. So, in various organizations that I saw people that had the business analyst title, they were often, maybe typists is too strong a word, but they go have meetings with the business people who would tell them a bunch of things. They would structure and format that into the system that they use, whether that's Jira or what have you, and then essentially bring that information via those systems to the programming teams. But there was not very much true analysis that was done. It was more a recording, a formatting, and a structuring of these things that were given. So again, even if that role exists in an organization, usually does not have the political capital, the seniority, the knowledge and skills to be able to significantly push back and engage with business stakeholders to perform, this very necessary activity. And then subsequently things go poorly and the developers are like, why is the system performing so terribly? It's like, we built exactly what you told us to build, telling you that there would be problems along the way. You didn't listen, and this is what happened.
Here you have it. Have fun.
Right, and then it's only when they're in a great deal of pain that it's so what do we do now? That occasionally, somebody will send me an email and say, we're in a mess, we need help. But usually it's the developers that do that. But it's only a result of there being a mess and there being significant business pain associated with it, that the folks on the business and the management side are actually willing to listen for the first time and actually accept changes. So a lot of time what a consultant does is they come in at the perfect time when the conditions are just ripe for a whole bunch of discussions to happen that couldn't have happened before. And then it's, you need to make all of these changes. And, the developer's like, we've been saying that for years now. They don't listen.
Exactly. Yeah.
But the
that's what's always
comes
happened.
in and then they listen to them, and then, oh yeah, look at they're so smart. Why didn't you just do that from the very beginning?
And sometimes even what I've seen being on both sides is you sometimes have a consultant telling you what to do, but then you say, well, you have a good point, but you're lacking our contextual situation too much. So here's a slightly better thing that we already set for half a year or 1 year. Yeah.
Mm-hmm.
So if you're not careful enough, the consultant will bring you in a different, now
Mm-hmm.
me being a consultant as well, I always be careful. And great. I think, this ends this fireside chat. Thank you very much. I think you covered a lot of ground already. There's been tons of questions, so I hope, people have a lot more questions now. But I think you tackled the main discussions that we are having. So I'd like to thank you, and thanks for the audience of engaging with the questions.
If people want to go deeper into these things, again, there's only so much we can cover in an hour and 15 minutes. My 5-day course, the Advanced Distributed Systems Design, is online. There's a bunch of free stuff on there, as well as YouTube videos and whatever on the particular.net site. But it really does require going deep into it. And hopefully one of these days the courses will go back to happening in real life, in a classroom context, where everybody can travel, and sort of the high density experience of really dedicating time.
Yes.
There's a lot of unlearning and relearning to do in order to learn and apply these concepts correctly.
So please, we'll add that to the resources on the site and Twitter. Thanks, and thanks to the rest. For the people still watching or listening, we are also updating the site. So we're trying to add these resources to every session. So you can go to the session page of this session now. Also keep that discussion going there, because we now added a comment section to this to all the sessions. So people can keep interacting there, or else just go to the Slack channel. And thank you very much, and hope to see you in the future. Yeah, and
Christina.
And until next time. And I'm going to stop the live stream, and we can continue talking here. See how much time we have. But thank you for the rest. Bye bye.